Sometime in the next few weeks, without you asking it to, your body is going to start preparing for a disaster that isn't coming. It will quietly shift how it processes fat. It will nudge your appetite upward. It will make you crave things that are dense, rich, and calorie-heavy. It will pull you towards sleep earlier and tug you away from the cold. And if you give in to any of these urges, if you eat a little more, move a little less, feel a little slower and heavier as the days shorten, you won't be failing. You'll be doing exactly what your body was built to do. You'll be preparing for a winter that, in the modern world, will never truly arrive. Your body does not know what year it is. It does not know about central heating or refrigerators or the fact that your local supermarket has the same food available in January that it had in July. It knows light. It knows temperature. It knows the slow tilt of the earth away from the sun, felt through the skin and the eyes. And it responds to that tilt with a cascade of biological changes that have been running in your lineage for millions of years. Changes that once meant survival. Changes that now mostly just make you feel tired, hungry, and vaguely dissatisfied every autumn without quite knowing why. To understand why this happens, you need to understand what winter actually meant for your ancestors. Not the winter you experience, a minor inconvenience of coats and heating bills. The winter they experienced, the kind of winter that killed. For most of human history, and for millions of years before Homo sapiens existed, the cold season meant one thing above all else: food scarcity. Animals were harder to find. Plants were dead or dormant. Stored food, if it existed at all, was finite and dwindling. The body that survived winter was the body that had prepared for it. And preparation meant one thing: store as much energy as possible before it arrives. Neuroscientist and chronobiologist Russell Foster, who has spent decades studying the relationship between light and biological rhythms at the University of Oxford, describes the human body as carrying what he calls a deep time clock, an internal system calibrated not to minutes and hours but to seasons, to the annual rhythm of light and dark that has governed life on Earth for hundreds of millions of years. Your brain contains a structure called the suprachiasmatic nucleus, a tiny cluster of neurons sitting just above the optic chiasm, where information from your eyes feeds directly into your body's timekeeping system. When the light hitting your retina changes, when the days grow shorter and the angle of the sun drops, this structure begins to send different signals. Melatonin production shifts, cortisol rhythms change, and a cascade of hormonal adjustments begins, calibrated by your ancestors' experience of what shorter days reliably predicted: that cold and scarcity were coming, and that the body needed to act accordingly. One of the most studied aspects of this seasonal shift is what researchers call carbohydrate craving. In the autumn months, many people experience a pronounced increase in appetite specifically for starchy, sweet, and calorie-dense foods. For years, this was dismissed as purely psychological, comfort eating, cultural association with holiday food, nothing biological. Then came research. A 2018 study published in the journal Current Biology, led by researchers at Vanderbilt University, demonstrated that human metabolism shifts measurably across seasons, with the body's baseline energy expenditure and fat processing changing in ways that mirror seasonal patterns in hibernating and food caching animals. Your metabolism in November is not the same metabolism you had in June. It is running a different program. A program written for a world where November meant the last chance to build reserves before the long scarcity. This is why dieting in autumn is harder than dieting in spring. Not because your willpower is weaker, but because your biology is actively working against caloric restriction at exactly the time of year when your ancestors most needed to be storing, not burning. The same drive that helped your great-great-grandmother survive a Pleistocene winter is now manifesting as an extra slice of bread you didn't plan to eat. The body doesn't distinguish between a genuine winter threat and a modern autumn evening. It sees the light. It reads the signal. Go deeper than appetite. Serotonin, the neurotransmitter most associated with mood stability and a sense of well-being, is produced partly in response to light exposure. As days shorten, serotonin levels tend to drop in many people. The body attempts to compensate by craving carbohydrates, which trigger a temporary boost in serotonin production through a pathway involving tryptophan and insulin. This is not weakness, but a very old biological feedback loop, trying to regulate your internal chemistry in response to a light environment that no longer means what it once did. Psychiatrist Norman Rosenthal, who first formally described seasonal affective disorder in 1984, spent years documenting how this ancient light response system could tip into genuine clinical depression in some individuals when deprived of adequate winter light. A condition that responds dramatically to light therapy precisely because the underlying mechanism is photobiological, not psychological. But the seasonal body doesn't just reach for more food. It reaches for less movement. Studies of physical activity patterns across the year consistently show a significant drop in voluntary exercise and general movement in the autumn and winter months, even in populations with access to indoor gyms and no reason to reduce activity. The body is pulling energy inward, conserving, preparing to endure rather than perform. In the ancestral world, burning unnecessary calories in winter was potentially fatal. Rest was rational. The body that moved less and ate more in the cold months was the body that survived to spring. The body that kept sprinting through November, burning through its reserves, risked not making it. Your immune system also shifts seasonally, and the mechanism is the same. Researcher John Brewster and colleagues published research showing that gene expression in immune cells changes significantly across seasons, with inflammation-related genes showing higher activity in winter months. Inflammation is a metabolic expense. It burns calories, generates heat, fights pathogens. Ramping it up in winter, when your ancient ancestors were exposed to cold, crowded conditions and the accumulated stress of scarcity, was an adaptive strategy. Your immune system doesn't know that your winter conditions now involve a heated office and a grocery store. It's still running the old seasonal program. And then there is sleep. As the nights lengthen, the body's drive toward earlier and longer sleep increases. This isn't laziness. This is the hibernation gradient, not full hibernation, which humans never evolved, but the directional pull toward a lower energy state that conserves resources through the cold months. Sleep is the most energy-efficient state the body can occupy while remaining alive. More sleep in winter meant less caloric expenditure. Less caloric expenditure meant a smaller deficit to survive on whatever food remained. Your body doesn't know you have electric blankets. It knows the nights are long and it wants you horizontal. None of this is malfunction. All these responses, the appetite, the cravings, the low mood, the reduced movement, the early fatigue, was an exquisitely calibrated survival system in the world it was built for. The mismatch is not in your biology. The mismatch is in the world. You are running ancient winter preparation software on a body that will never face the winter it was written for. The scarcity, the cold, will not come. The food supply will not fail. And yet, the program runs. Understanding this doesn't make the autumn heaviness disappear, but it does change what it means. When you feel the pull toward the couch on a gray October afternoon, toward a warm bowl of something starchy, or an earlier bedtime, and a reluctance to go outside, that is not a character flaw. That is your body doing something it has been doing for millions of years, keeping you alive through a winter that, as every year in the modern world, will simply never come.